Okay, so yeah, if you don't know me, I'm Paul Anderson. I'm a lecturer here, teaching-focused lecturer. So my interest, or one of my main interests, is on developing teaching, and the main bit of that for me at the moment seems to be around these connections with industry, and that relates to my role here as careers tutor, where I work closely with Jim Reali over here too. So I'm going to be giving you a general context really today about where we are at the moment with connections with industry, and then going forward some ideas for how those could develop in the future. And just to make it clear to start with, when I say industry, I suppose it's a term that us in academia use for any external organisation. So it could be a traditional industry, it could be a government body like the British Geological Survey. We've got Ricky from there here. So I feel, we all feel, that connections with industry is very important, because our students who do our degrees, our earth sciences degrees, do go on to industry roles regularly. So we've got traditionally oil and gas, resource, geology. Increasingly now we have jobs in consultancy, so geotechnical consultancy and environmental consultancy, those areas as well, and many more too. So one of the questions around that we should be thinking as educators, so us at university, is what skills and experience do students need in order to go forward and be successful in applying for these jobs and functioning in these job roles? And how can our degrees facilitate what's necessary in order to do that? So, as teaching-focused lecturer, like I mentioned, and careers tutor as well, I felt like I was in a good position to think about these questions, to focus on those. And one of the solutions, and the solution we're focusing on today, is industry-based coursework. So industry-based tasks that students do which relate to their degree, but also form what we'd have as traditional internship experience, hopefully provide something useful for the company they're working for as well. And the three main ways in which this is currently done, they're very open to expanding those, but I'm just going to go over these three today in my short intro. Firstly, using software and technologies that are relevant to industry. So for example, mining software. We have a mining software package here. Adrian here is going to give us our keynote talk in 5 or so minutes about the use of drones in mapping, something that we don't do here in undergraduate mapping, but it is the future, so very useful to know about. Collaborative short projects as well, something that we've done. So these are projects within modules, so essentially little bits of coursework in modules. It's not a whole mapping project or anything of that magnitude, but something that would take 3, 4, 5 weeks to complete, one of your coursework assignments that students would do. I'll go on about specifics shortly on those. And then the third way that we connect with industry is collaborative major projects. So these are things like the geological mapping project, which we all know about, and the final year ESCInd project as well, if a student's doing the 4-year degree. So just looking briefly at each of these three ways we can connect as academics with industry. Here's an example for software and technology. So this is software called MindSight that we have. So it's software which is used professionally. It's used a lot in Australia and Africa for those big open cast mines that they have there. and it's used to model ore deposits, essentially. And those deposits are modelled from information we get from boreholes. So essentially we feed the borehole information in, it's two-dimensional information, and we come up with a three-dimensional model of the deposit, which is, the interpretation of that is aided by this computer software. So that's just one example of the kind of software we have. That's used in one of our final year modules. So the benefit of this, and for all the software we use, is that students gain experience in using this industry relevant software, and they're developing skills which are directly applicable to industry as well. So it makes your CV look better, makes the students more attractive to industry, and makes them more useful when they start their jobs as well. These collaborative short projects then, so what I've been involved in along this side of things is geotechnical site investigations. So the example I'm going to talk about is part of our final year, so third and fourth year module here, engineering geology and hydrogeology. So this was a coursework exercise which lasted about 4 weeks. And the coursework exercise was actually set by one of these external companies, so one of these geotechnical consultancies. So these are the companies who were involved in this project. I was in touch with these companies along with Roshni from the Careers Service, who helps to facilitate these things, and we talked about how we could set a project which would take the students around 4 weeks to complete. And the remit that we gave the companies, which was that it had to be something around site investigation, so quite a broad remit really. And we had some varied projects from Forkers here who were involved in former coal mining areas, grouting, etc., stabilising and making these areas safe, through to Rogers Leask. We've got Sean from Rogers Leask here, who had a completely different kind of project involving superficial deposits and the slope stability in relation to those. These were based on recent projects, but not necessarily live projects. In fact, none of these this time round were live projects. So in other words, the students weren't working on something which would go out to the client. So it was essentially a mock-up of a very recent project which that company had worked on. So the advantage of that was that the company had produced their report, their site investigation report on this project, so you could directly compare what the students produced with the model answer, if you like, so what the company produced on that site. And there was an experience for students to apply to these projects as well, so we had lots of demand for each of these projects. PGA was particularly popular because that was the closest one to the university, it turned out. So we had to do an interview process in order to decide who got these positions. So again, that's relevant skills which will be helpful for the students going forward and applying for real life, not non-mock positions. And what the companies provided for these projects, they gave weekly mentoring sessions in their offices. So the students each week travelled to the offices, which were all in the Midlands area, if you know these companies. Furthest was Forkers, which is in the Black Country, so all within 10 miles certainly of the university. And they were guided through, firstly, the background of the project, and secondly what they were expected to do in their site investigation reports. So very much guided by the companies, these projects, and that's the theme really of these collaborative projects. We want to make them useful for the students going forward. So I'm keen really to get as much input from companies as possible and make them as realistic as possible, these projects. And then finally, our collaborative major project, which we've got 3 students here who are involved in at the moment. So these mainly have been the geological mapping projects. You all know about these. These are 5 or 6 week projects where you go map an area, usually somewhere quite remote and mountainous, and then have a write-up over the following months. But these were different in that, well, from at first 2 years ago, they've been designed in collaboration with industry partners. So these have been quarrying companies so far. So there'll be a quarrying company such as Tarmac, Hanson, we've had as well. BGS have been involved as well, slightly different type of company. But the company generally has a problem that they want to have looked into. For example, one unit which they're not quite sure where it crops out in the quarry, one boundary that they want to pin down. So rather than like you do in the traditional mapping project, which is map a whole broad 20 square kilometre area, the students will be focusing in on one quarry, one unit or one boundary perhaps, and doing a much smaller scale mapping project, which is equally as time intensive, equally as much effort, but the results are very focused. So focused on this area which will be of industrial importance. And we've had some real success with these projects so far. We're on the second round of them now. So companies we've had involved in these projects, mapping real world relevance. We have Tarmac, Breeding Group of 3 students here are involved with. BGS, we had a different kind of project. So this was for a student who couldn't map in the field. So it was a project Ricky here organised involving the subsurface of London. It's a really interesting project, come up with some great results there. Hanson and this company Quarry Arts, who were more interested in outreach. So there was an outreach element to that project as well. So as I said, we're currently on the second round of these projects. First year we had 9 students. Second year we actually had 20 who signed up, so they wanted to do these projects. So showing how there is demand for them. Unfortunately, we didn't have enough projects for everyone, so we had to do interviews and ended up with 14 students doing these projects. And some of the findings have been great, really encouraging. Last year, we had a project with Tarmac, which is potentially going to reduce the amount of waste which is produced in quarrying. So some real worthwhile findings there. Essentially it was a geochemistry project, and the amount of waste around faulted zones in quarries was analysed. So they were able to show this is a zone where you'll be able to extract from, here's a zone where extraction will be no good. The waste, the contamination level is too high. Then also, just to mention, we've had 4th year, so ESCInd dissertations as well. So this is the major project which students do if they're doing a 4-year ESCInd degree. These have traditionally been very academic, but now we also have this practical theme as well with these projects. And the 2 we had last year, which I supervised, are with the BGS, Ricky again here, and Hanson, the quarrying company. This is the poster produced by Ellis Hammond, who worked with Ricky at the BGS. He was looking at the application of 3D visualization software, this software which the BGS have, and how that can potentially improve mapping. So following the theme that you'll see in Adrian's talk about drones, this mapping which you can do from an office and save your time and resources, really. So yeah, as I mentioned, the BGS project, 3D visualization, and then we had this Hansen project looking at dewatering of a quarry, and that was something that which fed towards an environmental impact assessment. So the theme we'll see with these larger scale projects, the collaborative major projects, is that all of the ones we've had so far have fed into something which is useful to the company. So that seems to be the difference between the little bits of coursework which we have, which are more mock-ups, compared with these large-scale projects, where students are actually working on something with real-world relevance that they can potentially publish at the end of things. Just finally, to mention a few challenges, so I know we need to get on. Student expectations is something which has been a challenge. I think this time round, with sort of preempting that, hasn't been so bad. But one of the things is when students are mapping in quarries, having access to exposures. So previously, when they've mapped field trips, etc., you've been able to get up and touch the rocks, get as close as you like, and examine them, take samples, etc. Whereas in quarries, there's a lot of health and safety to think about. A lot of companies don't like you going up to the rock surfaces, rock faces at all. So that's a challenge to get around. There is software, so there's phone apps, etc., where you can measure structural readings, strike and dips, etc., without getting access. So we have tackled that issue this time round. Timescales for planning projects, it's something which has been a bit tricky, because obviously we're working between academia and industry, and the timescales which students have for choosing, planning and starting work on their projects might not necessarily fit with when companies know what projects are going to be available, when companies have potential supervisors to help out with those projects. So it's really making that match between what's available and who's available to do it. 2 sets of supervisors. So you've got your supervisor here, which has been me in these cases, and then an industrial supervisor, a supervisor with the company. So who to listen to? That hasn't really been an issue actually, but potentially that could be a challenge. Ownership of ideas is one that I think we probably need to discuss. So if students are doing work from a university side, the university might think that's academic, and the university might want to publish it, but then the company might also want to publish it, and how do we work around that? I don't know. So it's something we need to discuss going forward. And like I say, we're having this discussion session later in the afternoon, a session I'll lead on the challenges with these sorts of projects. So we'll hopefully get into some of these issues and get some of your ideas on these things too. Finally, let's talk about future prospects, and this is something hopefully which some of you will be interested in here if you're thinking about maybe offering or expanding one of these sorts of projects. So from our perspective, we'd like to develop the range of projects available, expand those, and improve what we offer to students as well by providing guidance, which we are doing this second year round, certainly with the mapping projects. We've got some money potentially which we can invest. So we're having a talk on software and technologies. We need to have a think about what's necessary for students to gain experience of, what do we need to have here for students to practice using. There will be a new module from 2019-20, so the following academic year, which is called a professional placements module. So here will be the opportunity for students to do longer placements. These are placements which will last 1 semester. So that's something which going forward, there could be potential opportunities there. Something which I would like to do is develop a network of students who've gone through this process. So we're just starting to have students who've gone through this process, who've graduated from the first set of industry-based mapping projects, and I'd like to keep in touch with these and develop a network who could potentially help students in the future going through similar processes. And then there's, of course, the idea of expanding these projects. So this is more with a research focus, this point. So there is funding available, government funding, for larger scale projects, so PhDs and postdoctoral research placements as well, so projects lasting a couple of years, 2-3 years perhaps. There's this one called ARLI, so it's alternative raw materials, essentially that's looking at. So this will have close links to quarrying, and the government actually provide all the funding for that. This would be a small scale project involving waste management in a quarry, perhaps. And the government provide all the funding to that if we have an academic partner who's partnered up with a small or medium-sized enterprise, so an SME. So that's something I only actually became aware of last week when I went to a similar conference in environmental sciences. And then we have a KTP, which is a knowledge transfer partnership. This is a bigger scale project, so this would be like a postdoctoral project, a 2 or 3 year one. So this would be if we had a problem which we know is going to take a lot of research, and that would involve the government providing a third to half of the funding for that project, as long as we have an academic partner along with an industry partner involved in that. So things to discuss further perhaps. And then from an academic point of view, pedagogic research, so research based on teaching and teaching quality, on the value of this kind of learning, this work-based learning, and hopefully that will build a case for further investment in these things. Okay, so thanks, and I'll pass on to our keynote. Adrian will be telling us about drone technologies.
Half an hour late, and I'm speaking for an hour, so I want to get a drink now.